Kenya Certificate of Secondary Education KCSE. 232/1. Physics. Paper 1. Section A, 25 marks. Determine the diameter of the object using the meter rule shown in figure 1 below. 1 mark. A uniform meter rule is balanced at the 30 cm mark when a load of 0.8 N is hung at the 0 mark as shown in figure 2 below. I calculate the weight of the meter rule 2 marks. E. Indicate on the figure the position of the center of gravity 1 mark. In the figure 3 below, explain what makes the rubber sucker stick on the flat clean surface. 2 marks. A mass of 50 grams was suspended from the lower end of a spring. If the spring extended by 50 millimeters and its elastic limit not exceeded, determine the spring constant. 2 marks. In an experiment, a student heated water containing a crystal of potassium permanganate as shown in figure 4 below. Figure 4. I indicate on the diagram the observations made. 1 mark. E. Explain the observations made. 2 marks. A log of wood of weight 1000 N is being dragged along the ground at a constant speed by a horizontal cable in which the tension is 200 N. What is the coefficient of friction between the wood and the ground? 2 marks. When a mercury thermometer is used to measure the temperature of hot water, it is observed that the mercury level first drops before beginning to rise. State the reason for this. 2 marks. Figure 5 below shows air trapped by a mercury in a glass tube. The tube is inverted in a dish containing mercury. Given that the atmospheric pressure is 760 millimeters of mercury and the height of mercury column in the table is 500 millimeters, determine the pressure of the air trapped in the tube in mmHg. 2 marks. A person weighing 500 N takes 11 seconds to climb upstairs to a height of 3.0 meters. What is the average power output? 2 marks. Figure 6 below shows a marble resting on an inverted bowl. Marble. Figure 6. What is the state of equilibrium of the marble? 1 mark. Explain why water stored in an earthen jar becomes cooler than that which is stored in a metallic jar. 1 mark. Name one factor that affects surface tension of a liquid other than presence of impurities. The 1st of March. The length of a block of wood was found to be 9.42 millimeters. If the micrometer screw gauge used to take this reading had a zero error PF 0.08 millimeters, what was the exact length of the block? 1 mark. A ball rolls from a table 1.5 meters high at a horizontal velocity of 2 meters per second. Calculate the distance from the foot of the table at which the ball hits the ground. 2 marks. A box mass 5.0 kilograms is pulled from rest by a horizontal force of 2.0 N for 2 seconds. Assuming there is no frictional force between the horizontal surface and the box. Find the distance covered by the box. 3 marks. Calculate the kinetic energy gained by the box. 3 marks. Calculate work done in pulling the box. 2 marks. A. When 400 identical lead balls were carefully added to a measuring cylinder containing 35 cc of water, the level of water rose to 83.2 cc mark. When 300 lead ball were removed, the measuring cylinder and its remaining contents weighed 137.4 g. The same cylinder weighed 32.5 grams when empty. Calculate. I. The volume of 1 lead ball. 2 marks. E. The density of lead in gram per cc, correct to 2D. P. 3 marks. E. The average density of 35 cc of water mixed with 400 lead balls. Density of water equals 1 g per cc. 2 marks. B. A 180W heater is immersed in a copper calorimeter of mass 100 grams containing 200 grams of alcohol. When the heater is switched on, after 36 seconds the temperature of calorimeter and its contents rises by 120 C. If specific heat capacity of copper is 400 J/kg. Determine I. Heat lost by the heater. 2 marks. E. Heat gained by calorimeter and alcohol, if the specific heat capacity of alcohol is Ca. 2 marks. E. The value of the specific heat capacity of alcohol. Ca. 2 marks. A block of mass 2 kilograms is accelerated steadily to a velocity of 10 meters per second from rest in 4 seconds. Calculate. I. The force needed to accelerate the block. 2 marks. E. The energy gained by the block. 2 marks. E. The momentum gained by the block. 2 marks. I. The time needed to bring the block to rest under a constant opposing force of 2N. 2 marks. A. Define acceleration. 1 mark. B. The figure below represents the velocity, time graph for a lift in a FIA center house. I. Describe briefly the motion between Iowa. 1 mark. AB. 1 mark. E. Calculate. I. The acceleration of the lift between B and C. 2 marks. Two. The total distance traveled by the lift. 2 marks. C.A. pulley system has a velocity ratio of 3 and raises a load of 4.2 and a distance of 10 centimeters. I. What is the distance moved by the effort? 2 marks. E. If the MA of the pulley system is 2.5, what is the effort required to lift the load stated above? 2 marks. E. Calculate the efficiency of the system. 2 marks. A. A watchman uses a bow to throw an arrow of mass 0.2 kilograms vertically upwards. He stretches the bow by 0.15 m with a maximum force of 100 N. Calculate I. The energy transferred to the bow. 3 marks. E. The speed with which the arrow leaves the bow. E. The greatest height attained by the arrow. 3 marks. IV. How long does the arrow remain in the air? 3 marks. B. A bicycle tire is pumped to a pressure of 2.2 x 105 Nm. B. A bicycle tire is pumped to a pressure of 2.2 x 105 Nm to a 230 C. After a race, the pressure is found to be 2.6 x 105 M2. Assuming the volume of the tire did not change, what is the temperature of the air in the tire? 2 marks. Form 4. Physics Paper 1. Marking Scheme. Section A, 25 mks. Diameter of the object equals 5.4-4.7 centimeters equals 0.71. Sum of the anti-clockwise moments equals sum of clockwise moments. The rubber sucker sucks air out and creates a low pressure zone inside one. The atmospheric pressure outside being higher presses the rubber sucks against the flat surface, hence it sticks. Point 1. From Hooke's law. E. The heart source set the water in the beaker in motion, i.e., convectional currents which moves in anti-clockwise direction, hence the potassium permanganate moves in the direction of the current. The glass bulb expands first, increasing in volume inside, hence mercury level drops first. Mercury then expands at higher rate more than glass, hence it rises. Point 1. P. Atmosphere. The earthen jar has pores that promotes cooling by evaporation while the metallic jar has none. 1. Temperature 1.